All right, guys. So today we're starting the Flipping the Classroom, where we watch the videos beforehand and work on homework during class. So make sure you have your notes filled out because I will be checking them Monday morning. So we're going to talk about parallelograms today. And a parallelogram is just a quadrilateral, a closed figure formed by four segments intersecting at their endpoints. So we've seen several of these. A square or rectangle would be a quadrilateral. We also have shapes that can look like this, and then that V shape that we kind of looked at when we were doing polygons. Specifically, though, a parallelogram, it's a quadrilateral in which opposite sides are parallel. So generally, we draw them like this, and of course, that would be a perfectly straight line. And what we know is that this side is parallel to that side, and this side is parallel to that side, which tells us an enormous amount of stuff. But there's other types of parallelograms as well. Rectangle and square are both parallelograms. We're going to start off by talking about diagonals. So I'm going to draw a rectangle because it's easier to see in a rectangle. So this is a parallelogram, and diagonals go from one corner to the other. And there's two in each of those. My lines are not very straight, I apologize. So those things right there are the diagonals. Okay, so there's a lot of rules that go along with this, and that's what we're going to do today. So example one, it says the parallelogram at the right has four vertices. What are they? Well, that's pretty easy. I've got M, N, Q, and P. So the vertices are just where the sides meet. How would we name this? Now, we kind of did this with triangles, but since it's a quadrilateral, we just draw a little quadrilateral in front of it, and then you start anywhere and go in order. So like M, N, P, Q. You could say N, P, Q, M, but you have to go around the track. Like if you said this was a quadrilateral, I don't know, Q, N, M, P, that would be incorrect because it goes like this, from Q to N to M to P. So it has to go around it like it's a track. So that would not be good, okay? Name opposite sides. Well, I have segment MQ, and that would be opposite segment NP. But we also have those two, the right and left side, so that'd be segment MN is opposite to segment PQ. So pretty easy stuff right there. Opposite angles, and this is going to be important in just a second. Angle N is opposite angle Q, and angle M is opposite angle P. All right. We also have consecutive angles, and this may be a little bit more tricky. These are angles that follow each other. Like, for example, one set would be angle N and angle P. So these two angles right there, they're consecutive. They're in an order. But we can also say angle P and angle Q. We have angle Q and angle M. Then we have one more set. It looks like angle M and angle N. So any two angles that are right next to each other are going to be consecutive angles. And then we have the diagonals. And I know they're not specifically drawn, but we can draw them in. There would be one. Here would be the other. So it looks like I have segment MP and segment NQ. So that's basically all the important parts of a parallelogram. It's important to know those because we're about to learn a lot of rules about it. So let's look at some of the rules. The parallelograms have 5 properties, and we already know some of them. Opposite sides are parallel. So I know that this side is parallel to that one, and this side is parallel to that one. We already knew that one. We also have that opposite sides are congruent, kind of like when we have squares and rectangles. So this side is congruent to that side, and this side is congruent to that side. I guess I'm going to put the double lines there to differentiate. Sorry about that, guys. Opposite angles are congruent. So this angle and this angle are opposite. They're congruent to each other. This angle and this angle are opposite. They are also congruent to each other. Let's see, our next one is that consecutive angles are supplementary. So I'm just going to kind of draw a little thing here. I'm going to say if I took these two angles, they're supplementary. Which means, and you don't have to draw this, these two would be supplementary, these two and those two would be supplementary. I'm going to get rid of those because that's a lot of messy stuff. And then the last one is that diagonals bisect each other. And if you remember, bisecting means they cut each other in half. which would mean this piece right here is congruent to this piece, and this piece right here is congruent to that piece. Now, that's a lot of stuff, and you absolutely have to know it. That's how we're going to answer the questions that are about to happen. So let's look at example 2. It says, complete each statement regarding the parallelogram below. The first one says, name the parallelogram. Well, I'm going to name it one way, but there's multiple names you could use. I'm going to say parallelogram ABCD. But remember, you have to go in an order. So like DBCA would not work. It needs to go around the track, not through it, okay? Then it asks, side AB is parallel to what? Well, here's side AB over here. The opposite side is parallel to it, so I'm going to put segment DC. Then it says segment DA is congruent to what? Well, DA is this top one. Opposite sides are congruent, so I'm going to say segment CB. It says angle CDA is congruent to. Well, here's angle CDA. Opposite angles are congruent, so I'm going to say angle ABC. Then last it says segment DE is congruent to. Well, DE is part of this diagonal there, and since diagonals bisect each other, the other part of that diagonal would be congruent. So I'd say segment EB. And of course, you could switch all these segments, like on the top one it could be CD or BC or BE on any of those. So let's answer a question now. It says, if ABCD is a parallelogram, the measure of angle A is x degrees, and the measure of angle D is 2x minus 3. It says find the value of x. So the first thing you need to do is draw it. Doesn't matter what kind of parallelogram you draw. I'm going to draw the rectangle because it's pretty easy to see, and I'm going to name it A, B, C, D. It tells me that angle A is x degrees, and angle D is 2x minus 3 degrees. And they want us to find x. Well, if I look back up here, it says that consecutive angles are supplementary. Well, those are consecutive angles, so they should have a sum of 180 degrees. So we add them up, and then we solve for x. So I have x plus 2x minus 3 equals 180 degrees. That's 3x minus 3 equals 180 degrees. I'm going to add 3 to both sides, so 3x equals 183 degrees. And then I divide by 3, and I get x equals 61. Now you can plug that back in and check if you want to, but usually you guys do pretty well at that stuff, so I'm not too worried about you making a lot of mistakes. All right, let's go to the page. What it tells me about diagonals up here is that diagonals bisect each other, so they cut each other. You know is that opposite angles are congruent. X, consecutive angles are supplementary. The last page. Example 4 says XYZW is a parallelogram with diagonals XZ and YW that intersect at point A. So that's a lot of stuff. I'm going to go ahead and sketch this. I'm going to make it pretty big. Let's see. They told us that this is XYZW. And they tell us it has diagonals XZ. So I'm going to sketch that in. Whoops. And YW. It says that they intersect at point A. Now I need to fill in the rest. It says if x to A is 3m, that's just like an x, and z to A is 5m minus 4, it says find m. So if I look back at the last half, so if this is congruent to that, then those expressions are congruent, which means they're equal. So I'm going to write 3m equals 5m minus 4. And then I'm going to solve. So I'm going to subtract 5m from both sides. 3m minus 5m would be 2m. Sorry, negative 2m. And that's going to equal negative 4. And then, of course, I divide by negative 2. That gives me m equals 2. All right? So if we plug those both in, both of those would be 6 units long. So if you have any questions over that, of course, ask tomorrow. But I think that's pretty straightforward. This is a big one. This is a lot of stuff on this part. It says for each parallelogram, find the value of x, y, and z. Now, some of these are pretty quick and easy, and some of them are a little tougher. So I'm going to look at number 5 first. And I've got lots of angles, and then I have this exterior angle. But one thing that well, if I look at this 80-degree angle and this angle, those are opposite angles. That means X is 80 degrees. And I'm going to go ahead and fill it into my picture too. It might help in just a little bit. Now, something else that I know, if I'm looking at Z, so I know that Z plus X should equal 180 degrees. So I'm going to have Z plus 80 equals 180. And you may not need to write that out. That's fine. Which means Z equals 100 degrees.